Hello everybody and welcome to the third part of our linear algebra review for our course Machine Learning. So, in this part we're gonna learn about some matrix properties and inverse, transpose and this kind of stuff. So, we want to ask a question which is matrix multiplication commutative? In previous videos we learned how to do matrix multiplication, and now we're gonna see some properties. The first property, is it commutative? What do we mean by commutative? For example, in scalar multiplication, 3 multiplied by 5 equals 5 multiplied by 3 and equals 15. That's in the normal multiplication. But in matrix multiplication, can we say that if we have two matrices A and B, that A multiplied by B equals B multiplied by A? Can we say that? The short answer is no, we can't. So matrix multiplication is not commutative. A multiplied by B is not equal to B multiplied by A. Let's see an example. For example, we have this matrix, 2 by 2 matrix, and multiplied by another 2 by 2 matrix. By the way, when the dimensions of the matrix are equal, like the first dimension, the rows and the columns are equal, we say it's a square matrix. So now we have 2 by 2 matrix multiplied by 2 by 2 matrix. And what if we inverse the order? So we put the first matrix as the second one and the second one as the first one. The first multiplication give us this result. As we did before, 0 by 0 multiplied by 0 plus 0 by 1, that equals 0. 0 by 0 and the other 0 by 1, that equals 0. And 2 by 0 and 1 by 1, that's 1. And 2 by 0 and 1 by 1, that equals another 1. And here, in the second situation where we changed the place, so basically we took this matrix, we put it here, and we took this matrix, we put it here, we have this result, 0 multiplied by 0 plus 0 multiplied by 2, that equals 0. So 0 plus 0, 0. And now 0 multiplied by another 0, 0, plus 0 multiplied by 1, so that's 0. And 1 multiplied by 0, that's 0. And 1 plus 1 multiplied by 2, and that's 2. So 2. And so on. So you notice here that just by changing the position of matrices, we have totally different results. You see, like 1 1 2 1, so it's totally different result. And if by that example we make sure that matrix multiplication is not commutative. So is it associative? What do we mean by associative? Okay, it's all the answer is all here. So what do we mean by associative? 2 by 5 by 3 in normal multiplication is equal to 2 by 5 and all that by 3. But can we say in matrix world that A by B by C equals A multiplied by B the whole multiplied by C? Can we say that? The short answer is matrix multiplication is associative. So we can do that, and it's fine. Like the result gonna be fine. Okay. Now, what's matrix identity? Suppose we have a matrix called A, 1 multiplied by a is equal to a multiplied by 1 equals to a. So when we go back here, for example, when we go back to the question, is matrix multiplication commutative? We said totally no, but there is one exception. It's the identity matrix. In this situation, this can be this is scalar, like 1 by a equals a by 1 multiplied by 1 and equals a. So 1 in this situation, you're going to say, oh, but 1 is a scalar, it's not a matrix. Okay, there is some special matrices that they are called identity matrices. In this situation, 1 is the identity. So let's define what's an identity matrix I. The identity matrix I is n by n matrix. That means it's a square matrix, as I pointed out previously. So this is this is 2 by 2 matrix where the diagonal, this one, is 1. Let's see another example. This is also an identity matrix where the diagonal is ones and the rest is zeros. So that's the third example. So the diagonal is 1 and the rest are zeros. So from these examples, we can conclude a rule, which is identity matrices are always 1 in the diagonal and always zeros in the rest. You see, this is in the first situation, this is in the second example, and this is in the third example. So that is what it means to have an identity matrix. That's an identity matrix. That's an identity matrix. So this is 2 by 2, 3 by 3, and 4 by 4. So here is the definition. An identity matrix is a square matrix where the diagonal is ones and the rest are all zeros. Let's have an example. Let's say we have this matrix. This is 3 by 3 matrix. So definitely we need 3 by 3 identity matrix. What's the result? Yes, you guessed it right. Exactly the same. It stays the same because this is an identity matrix. So 0 by 1 equals 0, 3 by 0, and 1 by 0, and here we have 0. Then 0 by 1 and 3. Yeah, we did that, right? So let's go to the second one. 5 by 1, 5. So here's 5. 8 by 0, 0, 0 by 0, 0. So when we add all of this, it's 5. So 1 by 1, that's 1, plus 0 by 0, and 4 multiplied by 0. And all if we do addition, it's 1 because 0 is 0. So 1, here is 1. And so on. When you calculate this, you will find it exactly the same as the beginning. So always when you see an identity matrix where, again, the diagonal is ones and the rest are zeros, you directly know that it is identity matrix, so the result is the same as the beginning. So what's a matrix inverse? Simply, in scalar world, in the normal numbers that we know, for example, we have a number 3. The number 3, its inverse is 3 to the power of minus 1, or 1 divided by 3. That's the inverse. In the matrix world, first we have to point out that the inverse of a scalar, in this case is, for example, for 3, we have 3 to the power of minus 1. When we multiply them together, we have 1. is the identity. We said that 1 is the identity. So in the matrix world, if A is M by M matrix, M by M, what does that mean? Square. If we have a square matrix and has an inverse, why specifically I mentioned that it has to has an inverse? That means not all matrices has an inverse. For example, not square matrices. They don't have an inverse because we need like a square matrix to have an inverse. Then, if we have these two conditions, the matrix is square and it has an inverse. We call the inverse a minus 1, a to the power of minus 1. That's the notation for an inverse. Then, a multiplied by a equals a multiplied by the inverse of a equals the inverse of a multiplied by a and equals the identity. This is the identity. This is I, not 1. And you remember this? Do you remember this? You might note that this is the same when we presented. Let's go back. Yeah, the first question. The first question we presented. Is it commutative? So we said no, not commutative, except in the case where we are multiplying a by its inverse. So if we are multiplying a by its inverse, yes, it can be commutative. That means we can definitely uh, change the places, like a multiplied by the inverse equals the inverse multiplied by a and equals the identity matrix that we learned about previously. For example, A equals this matrix, and so A inverse equals, how do you calculate this? Even I don't know. So, I mean, I know how to calculate it, but it takes a long time. Here is the result. So you're gonna say, oh, what's that? How did you do that? That's the good part, because that's what we're gonna learn in the next video. I did that using R, and that's what we're gonna see together in the next video, how to do that using R, and having, like, you don't need to calculate anything. You're gonna have directly the answer for that question. What's the inverse of A? Yeah. Now matrix transpose. Transpose is actually easier than inverse. So let A be a matrix where A equals this matrix. The transpose of A, or r to the power of t, that's the notation of a transpose. We put like a t in the, like, to the power a to the power of t is this. So how did I come up with this? Simply, you take the matrix A, then you take the first row, you put it as a column. The first row, put it as the first column, and the second row becomes the second column, and the third row becomes the third column. So technically, it's just like changing the rows to columns in the same order. The first row becomes the first column, the second row becomes the second column, the third row becomes the third column, and that's how to do transpose of a matrix. Okay? So that was the third video. As I said before, the next video we're gonna see together. Like, I'm gonna introduce you to the R programming language, and the video after that is gonna be about Python. We're gonna just see just some basics, how to define a matrix, how to do some cool stuff that we already learned, like matrix addition, matrix multiplication, this kind of stuff. And yeah, it's gonna be cool, even better than theoretical work. Sorry. Okay, thank you very much. See you next video.